squeezed light, squid skin, and shortwave infrared sensors. That's this week on Light Matters. Hi, I'm James Lowe, and this is Light Matters for September 24th, 2014. German scientists have overcome a theoretical hurdle by transmitting a pulse of squeezed light over a long distance through the air in daylight. Researchers from the Max Planck Institute for the Science of Light sent a photon packet to the University of Erlangen-Nuremberg, a distance of 1.6 kilometers, over which it maintained its polarization state. Quantum communications using flashes of light is possible only if the constituent photons exist in the low-noise, squeezed state. This state is easily destroyed if the light passes through turbulence in the air, however. The researchers circumvented this problem by relying on polarization, which cannot be changed by turbulence. The study results hint at applications in quantum cryptography, such as detection of eavesdropping. The research was published in Physical Review Letters. New display technology is bringing scientists a step closer to metamaterials that mimic the unique optical properties of squid and octopus skin. Developed at Rice University's Laboratory for Nanophotonics, the new full-color display delivers bright red, blue, and green hues from 5-micron square pixels that each contain several hundred aluminum nanorods. In the study, the pixels' colors were fine-tuned in two ways. First, by varying the length of the nanorods, and then by adjusting the amount of space between them. This arrangement was shown to narrow the output spectrum to one color, rather than the typical muted shades produced by aluminum nanoparticles. In the future, the researchers hope to use this technique to create an LCD display that won't fade or bleach after prolonged use. Laboratory Director Naomi Hallis said the ultimate goal is to create materials that can sense light and react with full-color camouflage displays. The research was published in the Proceedings of the National Academy of Sciences. Last week, Photonics Media attended the grand opening of the new Sensors Unlimited facility in Princeton, New Jersey. The company is a subsidiary of UTC Aerospace Systems. It makes shortwave infrared cameras for industrial and telecommunications quality testing, as well as surveillance applications for the military. Silicon, plastics, and even smoke are transparent in the shortwave IR band from about 1 to 1.7 microns. This allows SWIR cameras to detect defects in silicon blocks used in solar panel manufacturing or to pick out hidden targets on the battlefield. The new 9,000 square foot plant features a suite of clean rooms for producing the indium gallium arsenide wafers that form the basis of the company's SWIR detectors, as well as packaging, assembly, and test labs. Sensors Unlimited employs 145 people, including 50 engineers. I caught up with Sales Director Bob Jones outside one of the new facility's cleanroom bays and asked him why the company made the move from its old facility across town.
As our customers' requirements for shortwave infrared products grows, so now we have room to grow, and with the new technology, we can look at things like further improving reproducibility, quality, and performance. And as I mentioned, there's a number of different things. So as was also pointed out, we're also really focused on continuing to grow our workforce. We have a lot of highly specialized talent here now, and so the company offers a lot of opportunity for training of those individuals, as well as additional schooling and those types of things to nurture the present workforce. But at the same time, we're also actively bringing in new talent. And so by doing that, with that combination of new talent, which is new ideas coming in, and an existing workforce that we have, you get more it's kind of a combination for innovation, right, which is supporting our customers.
We also talked with sales engineer Jim Belsky, who showed us what SWIR imaging looks like and how it's being used in one product intended for soldiers.
And in this case, even though we can easily see the trees and the lighting fixtures, we get a different color scheme because trees, plant material tends to be very reflective in the SWIR, and the metal then becomes very dark, and we can go ahead and, without training, we can identify the scene because it does look like a standard black and white image with just the different color clues and find out information. So this camera can, as shown here in full sunlight, can also go down to a very dim urban night lighting situation. One of our newest cameras for inclusion on like a helmet mount system becomes essentially almost the size of a pool chalk. In this case here, this is one slightly larger. This is also a 640 camera using very small pixels, and can achieve a lot of the same dynamic ranges and sensitivities that the other that our traditional cameras have. And in fact, we are using the core in this military product, which is a handheld system for the warfighter, can help go ahead and identify some specific battlefield lighting and give situational awareness to the soldier to make sure that either we have right targets or that we can go ahead and make sure not to get the wrong target.
We also visited with Business Development Manager Doug Malcho, who demonstrated a SWIR line scan system for industrial process monitoring.
The camera is shown here, has a lens on it, and it's imaging a bicycle wheel that's running at 12 kilometers per hour. On the wheel are strips with symbols that have been then painted blue or red. You can see the blue or red passing by. And on the readout screen, you can see those symbols scrolling by. In this particular case, the camera is running at 147,000 lines per second. The line time is 6.7 microseconds, and the exposure time is 5.5 microseconds. So it's a very short exposure time. You need a lot of light, and that's why you're seeing the bright light on the image. And this is illustrating some applications with paint, but also a biomedical application called optical coherence tomography, where tissue is a very scattering media, and by moving into our wavelength range, ophthalmologists and endoscopists are able to see into tissue with resolution of better than 10 microns with most systems, and advanced systems are getting down to resolutions of 2 and even 1 micron.
That's it for this edition of Light Matters. Email us with your questions or comments at lightmatters@photonics.com, and don't forget to follow us on Facebook and Twitter for news updates every day. Thanks for joining us. We'll see you next time.